Hello everyone. So as we have understood and learned about the CIA triad, now let's see a practical example of CIA triad. So for this, we are going to use a software which is HashCalc. Now what is this software? It is basically a hash calculator. So I guess you must have identified that we are going to test for integrity of CIA. So now let's quickly see how can we identify integrity for any data. So it is the practical time and let's quickly jump on to the practical. So for all the users which are on Windows based operating system, they can simply come onto this website and they can download HashCalc from here. It is a very small software and it is totally free of cost. As you can see over here, it says it's free and the size is only 468 KB. Now, as I'm onto a Mac operating system, I'm going to use a Mac based similar alternative software, which is again free of cost, and the working is totally the same. Both the tool works the same way. Now let me just open the tool and the name is Hashbox. So this is how it looks like. Now it asks you to drop files over here. So let's quickly create a file. So let's say the file content be the account number. And let's say the account number is 1234. Let me quickly save this file. And let's say we give the name as check integrity.txt. Let's save it on desktop and hit save. Now we have created a file. So as per the hash box, as we want to calculate the integrity, it is asking to drop files. So let's quickly drop the file. This is the file name, right? So let's quickly drop it over here. And here you can see it has identified for the integrity. Now you can see it has identified the integrity of the file, which is various checksums. Now you can see over here it is MD4, MD5, SHA1, SHA256 and SHA512. Now we are going to use the MD5 hash. Okay, so I'm going to export this hash into a file. So let's say we call the name as checksums.txt and we only want to export the MD5 sum and click on save. Alright, so now let's modify this file. So let's say the modification be the in the account number. So let's say 5 and let's save this file again. I have saved this file. Let me drop it again over here. The file name was check integrity, right? So let's identify the file name, pick it from here, drop it over here, and you can see the hash which has been generated. Now let's quickly see if the hashes are same or not. So the file which we created was checksums, and you can see over here so now we are going to modify the account number in the file. As you can see, we have modified it to 1235. Let me just save this file, and now we are going to identify the integrity of the same file but with different content or different data. This is the file that we created. As you can see, it is 12345. So let me just drag and drop this file over here, and you can see the new hashes which has been successfully generated. If I show you the comparison of the hash that has been generated, so let me open the file which is checksums, because this is the file which we created last time, and let me just zoom in a little bit. Now you can see the MD5 sum was this, and this is the MD5 sum which has been created for the new file with a change in account number. Now you can see over here this MD5 sum and this MD5 sum is not same. They are different. Now this proves that if there is any modification or alteration if done into any data, then the integrity is going to get hampered and it is going to change. All right. Now let's see one more test case. If I do this back to 1, 2, 3, 4 and again calculate the integrity, let's see what is the integrity that we are going to get. Now I want you guys to guess what is going to be the integrity of the same file that we are going to identify, or this checksum. Is it going to be the same as the first test case, or it is going to be different? So just pause the video for a few seconds, think about it, and you can resume it. So let me just drop the file over here and let's identify if it is same or not. And you can see the MD5 sum starts from 6A6 and ends with 40E, and it is exactly the same. And if you thought the same, then congratulations, you are right. We have identified the right checksum or the right integrity. Now, through this test case, we have proved that if the data remains exactly the same before the modification, the integrity remains the same because the data is now exactly the same as it was at the first point. There is no modification or alteration into the data. So I hope you guys understood this. Now I'm going to show you one more test case. I'm going to save this file again, and now I'm going to again check the integrity. This is the fourth test case that we are trying. I want you guys to again pause the video and tell me what is going to be the result. So let's quickly take this file, drop it over here, and let's see what is the result. Now, many of you must be thinking the checksum is going to be the same as the first test case because the account number remains the same. I have not done any modification. So let's see the MD5 hash, and you can see it is changed. Now, I hope every one of you must be surprised to see why is there a change in the result of the MD5 sum when the file content remains the same. We have not changed anything, neither have we changed the name of the file. Everything remains the same. The account number is 1234 as per the first test case. Now I have done a very minute modification into the file which may be unnoticed by you by our naked eyes. And you can see over here, this is the modification that has been done. I have added a white space over here, a blank space, and saved the file, because of which it has identified that there is a modification. So this basically proves that by adding a simple white space or a tab, the modification or the alteration into a file happens, and this will generate a new checksum, a new hash, and the integrity is going to change. Now let me remove the space, save the file once again, and now let's do the same test case. Let me drop it over here, and now in this last test case we are going to get the same checksum, and you can see it is exactly the same that we have identified in our first test case. So I hope you guys understood the principle of integrity and how it gets changed, how you can identify it using this tool. Now, what is the practical usage and example of this, you may ask, into your day-to-day daily life? Now, whenever you're downloading any files, any software from internet, you should always check its checksum. So this way you are aware that there are no modifications or alterations done into the software by anyone. For example, let's say you want to download a software which is VLC Media Player. So I'll go onto the website and I want to download this software. Let's say my network is infected. I'm into a LAN connected network and there has been someone who is doing man in the middle attack and has been identifying whatever activities I'm doing. Now, if he or she may change the downloaded data from the website to me in my network, I may download a malware. This way, I will not get what I was intending to. The integrity of the file will change in between. To stop this, we can identify the hashes of that file. For example, let me click on over here and you can see different file types you want to download for operating systems. And you can see I am downloading it for macOS. Here you can see display checksum and we have identified the checksum. So I do not want to download this for now. So I'm going to hit cancel and you can see the checksum which is presented over here. Now, once the file is downloaded, I'm going to drop it into hashcalc or hashbox and identify the SHA-256 checksum. And if it is exactly the same, then and only then I'm going to install it or interact with the file. So let me show you one more example. So let's say I want to use this software which is PuTTY, a very famous software which is used to doing SSH between clients. Now let's say I want to download this. Let's say I'm going to download a 64-bit version. Now this is a Windows software, so it is not going to run into my computer, but still it is enough to show you the practical. So you can see the file has been successfully downloaded into my computer. Now what I'm going to do is I'm going to use this file and drop it into over here, and let's see what is the integrity of the file. And you can see these are the checksum which are presented over here. Let's go down and let's just search for checksums, and here you can see these are the checksums which are present. Let's search for PuTTY because we have downloaded PuTTY and we have downloaded a 64-bit version. And you can see over here this is PuTTY 64-bit and this is the MD5 sum. Let me just zoom it a little bit for you and you can see it starts with DC, ends with F0F. Let's verify is it the same, and you can see it is exactly the same. It starts with DC and ends with F0F, which means we have downloaded the same correct file from the server because the checksums which have been uploaded by the sysadmin or developer matches exactly with the checksums that we have identified in our computers. Now this proves that there is no modification or alterations into the file that has been done into my network while the data was downloading. So I hope you guys understood this practical usage and it will be beneficial for you into your day-to-day life as well. Thank you.